Chalo, tell people are joining. Let's start. Hello everyone. I'm Vishesh Rabu. I'm sure जिन्होंने हमारा online session attend किया था, you guys know me. But for the people who are joining us for the first time and seeing me online, I'm going to be your instructor for the rest of the boot camp. So for AIML as well, AIML only. I to keep this inclusive, we'll try to keep this in English, only English, because the last session that we did offline was in Hindi. I got a few texts that I should be able to do it in English so that everyone understand. Though I asked in the class that if there is anyone who does not understand, but for the sake of the recording, because there are many people in the boot camp, and for the sake of the recording, we'll be doing it in English. But at any point, if there is anything you do not understand, feel free to tell me and I'll be able to tell you in Hindi or in a way possible, in a way where you understand it better. So feel free to interrupt me at any point of time. I guess we'll start now. I hope you guys did have a refresher of Python before joining because having that is really important. Although if you joined us in the session, you would have a pretty fair understanding of Python, though it was really basic, but you would have a fair understanding. Now, once you have that, we'll be moving to the advanced parts of Python and machine learning. Now, let me tell you guys, those who have joined us right now or did not attend a session before, the last session was purely basic Python. But today we are advancing a little bit. We are going to do the likes of machine learning and understand how machine learning really works. We are going to do the first few steps in the process of machine learning. We're going to understand how these models are built. Also, no theory, but yes, there are a few things that you should be able to understand in order to execute it, right? So we'll be doing that from scratch. I'll be sending a data set. So this is how the thrill starts. I'll be sending a data set on WhatsApp. You guys are expected to download it on your computer, all right? On your laptop or on your desktop, anywhere you are joining us from. Once you download that, we'll be using that further. But because it takes time, so for the sake of not wasting the time, keeping everyone's time in consideration, we'll be starting out with the Python, like some part of Python that was left. So we'll be covering that, and then we'll be moving on to the advanced part, the machine learning parts of things for which you joined for. So it's going to be one hell of a ride. It's going to be a bumpy ride as for sure. There will be some things that you do not understand, but there will be some things that you enjoy a lot. So I'll be here with you throughout the journey. I'm just sending you guys the CSV file that you need to download. And after this, we'll not use WhatsApp, we'll use a Google group, but I'll send that tomorrow. So for now, you can just download this file in your laptop, keep it there, we'll come back to it. So the next time we refer to this file, I'm hoping that every one of you have this file installed in your laptop. Now, for today, we are going to be using Jupyter. We're not going to be using Jupyter Notebook. Jupyter Notebook is a very fine thing, and you guys will be using that throughout, like while you're learning Python. If your laptop has a great capacity, then you can continue using Jupyter Notebook. But if your laptop is a bit old, does not have much of a RAM, then I suggest going with what we are going to do right now. So I'm going to share my screen. All right. I hope you guys can see my screen. Yes. All right. This is how we'll do it. So if you guys have a great laptop and the RAM and everything is good, you can continue on Jupyter Notebook. But if you do not have it, you can continue on Google Colab, the what I'm doing right now. The reason I'm suggesting Google Colab is because throughout the journey we'll be doing some like training some data sets which are like many megabytes, which is not like which takes time on a computer. It varies from computer to computer. That is why we'll be using Google Colab for this. What I'll do is I'll write Google Colab. It stands for Google Collaboratory. Okay. And once I open it, I'll be using new notebook. So I did nothing fancy. I just went to Google Colab and just opened a new notebook. And for the sake of you guys following us, what you can do is you can join from a phone, and then whatever we are coding along, you can just follow along with that. But I know it's easier when we are doing it offline, but bear with me. This takes time, but I'll try to make this as interactive as possible. So to get to the part where we left out, we left at for loops, right? So I'm hoping you guys did that thing. There will be a few basic things that we left. After that, we'll start jumping into the machine learning things. All right. So we'll start with for loops. And if at any point you do not understand anything, feel free to use the Q&A section. I'll be more than happy to assist you with it. All right. So let's start with for loop first. So there's a thing that we need to understand before proceeding further. So if we write for I in range 0, 5, and we print I. Okay. So we all know what this is going to do. This is going to okay, it's connecting. So if you run this and it says connecting to Python 3 Google Computer Engine backend, it'll take like a minute or two. But if you're doing it in Jupyter Notebook, it's well and good. So I'll also open a Jupyter Notebook just for the people who are doing it there. All right, so it's connected. Now, when I run this code, it'll give me from 0, 1, 2, 3, and 4. Now, why I did this is because I need you guys to understand what range is. Range is pretty easy to understand. It says, okay, so there's going to be a start value from where we're going to start it. So we said it's going to start from 0, but then we said 5, but now it's ending at 4. Why is that? It's because every time the end number that we give, it's going to end at the number preceding that number. So it's always going to end at, so if I write 6, if I want a number from 0 to 5, I'm going to write 0 and 6. It's going to give me 0, 1, 2, 3, and 4 and 5. Now there's one more thing. If I want to skip two numbers at a time, so I'll just write 2. This is called step, right? So if I just uh like execute it now, it's skipping 2 numbers, 0, 2, and 4. And it's not giving us 6 because here it was 6, but it stops at the previous number, which was 5. But if we had given 7, then definitely we would have had 6 as well here, right? That's the logic behind this. And the reason why I did this is because we are going to use this. And the people who have joined just now, there has been a data set sent to the WhatsApp group. You are requested to download it and keep it on your laptop because we are going to use it in a while. All right. Okay, now that is done. So for loop is kind of easy to understand, and you guys are welcome to execute it and see what is really happening. I'm going to copy a piece of code here, and I'm going to paste it. All right. I'll tell you what this does. So this is called initialization. Okay, this is Python. So initialization. All right. So we initialize a value. We have done this a million times in C and C++. So this is what it means actually. This means initialization. So we have initialized x as 0. Then we are putting a while loop. We say that while x is less than 10. So here x is less than 10. So until and unless x is less than 10, we want to print x is currently the value of x, and x is still less than 10. We are adding 1 to x. And how we are adding 1 to x? We are printing x plus equal to 1. This is this is just as uh, equivalent to x equal to x plus 1. All right. So here what we are doing, we are incrementing the value of x, right? So if we write x plus equal to 1, and then we do this, it'll execute till 10. Now the uh, range does not come in play here. It stopped here because we are saying less than 10. 9 is less than 10 and 10 is equal to 10. If I have added an equal to there, it would have executed till 10. So the range and the greater than symbol or any symbol that we use with an arithmetic operator, that is different. So this needs to be in your mind while we are using the data sets. Greater than, the arithmetic operations and the range operations are a bit different. This means the start, this means the stop, and it stops at the preceding value. And then a step, how many steps it has to take, how many numbers it has to skip, right? This is what I had to do. Or there's a function part, but we'll do functions when we are like approaching them. Now, I want you all to download the dataset on your laptop, and now we load that onto our Google Colab. So I'll tell you how to do that, but I am hoping at this point, and if at any point you feel that I'm going too fast, feel free to use the chat box. All right. So here's the thing: you guys need to have the dataset in your laptop, and after you have it there, we'll create a new Google Colab notebook. How do we do that? We create file, and I suggest you do this in Google Colab so that when the dataset gets a bit bulky, it does not take time on your laptop. You are free to do it on your Jupyter notebook if your computer RAM is good. So what we'll do is we'll go file and we'll go new notebook. All right. This is what is needed from you now. Now, before proceeding, I need I need to tell you guys something about machine learning process, how machine learning actually works. So before coming here, let's understand a bit of a theory. This is not theory, but something that needs to get into our minds before approaching the main topics. All right. So what I'll do is I just all right. Okay. So let's start. So now we are getting into the big games now. This is what we mean by machine learning. So whenever we are building a machine learning model, there are a few things that we do. Uh, First of all, where what is machine learning? You all know we are training the model or the machine learning. We are training the machine to an extent to do some tasks that to predict something that we already have given a data to use upon. For example, I have a salary with me, like employees' salary with me, and which has increased with a certain amount of percentage every year. Now, I don't want to do anything. I want the AI or the machine learning model to do something for me. I wanted to predict that, okay, after a certain year, if the trend of say 10% goes on for a certain years, how much of the increase in salary will there be? This is what we are trying to make the model predict. And this is somewhat of a basic example to understand what it actually means. So machine learning comprises of three parts. And all the things that we are doing in machine learning is done on a data set. So the data that I sent you, we'll be using that to do these predictions. So we'll start, but let's just understand a bit about machine learning. Okay. So it consists of three parts. First is data preprocessing. So what does data preprocessing mean? We have a data, right? You can go on Kaggle and you'll get a lot of pre and raw data sets. What does raw data set means? You got some data, you copy and pasted it. You have no idea if it's correct. You have no idea if it's really ready to be worked upon. Because see, it's a machine, right? It does not know if the data is correct. It does not know if the data is ready to be worked with, right? It is a machine. We have that capability or intelligence with us to understand, okay, this data has a missing value, this data has this discrepancy. We have that intelligence inside of us, but the machine doesn't. How do we tell the machine that okay, the data is good, you can proceed with the next step? So first of all, we import the data. We're going to do that today, so stay tuned. We clean the data, and then we split the data into training and test set. I'm going to come to this. What is training and test set? Cleaning the data means, for example, there are some missing values. For example, if the data is, if we want to compare the data, for example, I'll come to that part. But for example, there are A, B, and C, and we want to compare that if B is closer to C or B is closer to A. How do we do that? We do that with cleaning the data. Feature scaling, we'll come to that. Then comes the model. Now the data, the training and the test set is all done. We know that, okay, the training set is there, the test set is there. Now, what do we want to do? We want to build the model. What does the model do? What the model does the work for us, right? So we'll build the model, then we'll train the model, and then we'll make predictions. Simple as that. So it's like a normal way of doing things, right? We build it, we train it, we make the predictions, and then we evaluate it. So there are some performance metrics. Okay, the machine learning model has made the prediction, but how do we know that if it has made the right prediction? We'll come to that. There are also ways to predict that, and then we make a verdict. Okay, my model has predicted its data. If it's correct, then well and good. If it's not, we'll do that again, right? So this is what it means. Now let's come to training set and test set. What is this? Now we've got a whole lot of data, which is 100%, right? We can understand that it's 100% data. Let me make the circle a bit. All right. So we have got a data which is 100%, right? It's the all the data that we have. Now to make the data, to train the model on the data, what we do is we create a training set. Sounds like a normal English, right? Training set. So usually the normal models that we pick, what we do is we take 80% of this and we categorize it as training data. All right. And then we take 20% of the data and then we categorize it as test data. Now, everything that we are going to do, for example, we are going to clean it, we are going to build the model with anything and everything that we are going to perform in a machine learning experience is going to be with the training data. We are not going to touch the test data. The test data is going to be raw, right? Although it'll be cleaned, because we need to make sure that if we are giving it to the model, it does not get confused with some missing values or something. So it'll be cleaned, but that's all, right? So here, if you see, we have cleaned the data first, and then we have split it into training and test set, because cleaning is necessary. Now, anything and everything that is done, it's done on the training data. We do not touch the test data. We have given no information about our model to the test data, and it makes predictions on the basis of it, right? Now, in any data, we have a dependent variable and we have an independent variable. For example, if we want to predict a sale price of a car, right? Then what is the dependent variable? So, for example, okay. So in any data, we're going to have two types of variables, a dependent variable and an independent variable. Sounds easy. Now, what is this? Dependent variable is something that we are going to predict. So we already have a sale price, right? So for example, on the basis of A, B, and C, the sale price is 1,000. Okay. Now all, and this continues for some rows or some columns, and then it ends. This is the trading data. Now the thing that we want the model to predict, we want to predict it for the sale price for the next amount of data, right? So the column that it's going to predict, it's called dependent variable. Sounds good? And in any data, the most of the questions, if you have any questions, you can just tell me. I'll not be able to check it because I'm screen mirroring right now. So the in most of the models that we build, the last column that is there is the is what we are going to predict. Okay. When we use the data we are using, I'll tell you these things again, so it'll be visualized really well. So the last thing is the dependent variable, right? The last column. And these three are the features. So how the predictions is going to be made based on A, B, and C, because these are the features that it uses. For example, the mileage, the age of the car, and what we are going to predict, the sale price. Sounds simple, right? So with the features, the predictions are done. Now we'll come to feature scaling later. So we'll come to this later. Now let us understand a bit about. Now let's really use the data. Theory बहुत हो गई. Now let's use the data. ठीक है? So I hope you guys have used the data in your, like, install the data or downloaded the data in your computer, and then okay. Then what we'll do is we have created a new collab as well. So what we'll do is we'll just type data preprocessing. Okay, because that's what we are going to use. So we'll write data preprocessing dot ipynb. That is IPython notebook. Okay. So now we will start using it. Here comes the part. Now you're actually going to implement machine learning. A pretty big achievement. Now you're going to enhance your knowledge of machine learning. So before that, what we're going to do, we're going to click the file icon here, and then it's allocating the runtime. It might do for you as well. It just takes a minute or two. All right. All right, it has done that for me. So you don't need to touch this. You don't have to do anything with it. What we'll do is it's just connect it. So it's mine is done now. So what we'll do is we'll just click the upload button. Okay. When we click the upload button, we'll go. So for me, the data is in data, like it's in my downloads folder. Wherever it is saved for you, you'll just go and you click open. Okay. And then it's here now. Now that's done. This is the first part that you will have to do. And if you have done this, then you can give us a thumbs up. And I'm sorry, I'm not able to because see, once you guys are in front of me, it's a bit easy. But here I do not have my team with me because it's night, so I did not tell them. So I really hope that you guys are following along. Okay. And if at any point you have any questions, feel free to, you know, unmute your mic and tell me. Okay, so we have uploaded the data here, and it's right here. Now we'll start writing the code from scratch. So if I'm like you, I have no idea of what Python is. I'll try to explain it to you line by line. IDE, you can do that, but just make sure that your laptop is a bit, if your laptop is a good RAM, then you can go ahead. But obviously, this data is a bit small, so it doesn't matter. So you can do that in your IDE, but it's really suggestive that you do it on Google Colab because it's good. It's a really good practice. Okay, because I'll be sharing this whatever we are doing right now. I'll be sharing this in the WhatsApp group as a link to this Google Colab notebook. So I hope you understand. Okay. Now, what we'll do is we'll import a library. Now, what libraries are? Understand it as like a C++ library we used to import. For example, import stdlib. I am not sure what it was, but yeah, something like that. Conio.h in C and things like this. Okay. So what we'll do is we'll import a library. And how do we do that? We write import and we write the name of the library. So this is the name of a library, NumPy. If you had Python in 12th, you might have a knowledge about NumPy. But for now, we're just going to write it as NumPy as int. Now, what does this mean? I'll tell you, but let's just write the code first. Then we're going to import another library, pandas as PD. Okay. And okay, I shouldn't have executed it, but okay. Import matplotlib.pyplot. So matplotlib is a library, and inside the huge library, we want only one thing that's called pyplot. Okay. So how do we access that? We access it as dot. So if you have if you have an understanding of object oriented programming in any language, how do we access a class? We access it with a dot, right? So this is what we're doing here. It's a whole class of library. We are accessing a pipeline, which is an object, right? So as plt. Now let's understand what is this. So we are importing a numpy library. So if I just write this code, it's correct, no errors here. But to make our code more readable, what we do is we write as, which means we'll use the numpy library as np. So now the library is imported, but to use that library, we'll use now np. Okay. And it's not like you only have to write np, you can write anything. Ng, js. Just remember the name that you write is what you're going to use further. So for sake of this tutorial, we are only using np. Pandas is also a library. It allows you to, so numpy allows you to create arrays and plays, you can play with the arrays. Pandas allows you to create data frames or read the data that we just uploaded, right? So that is also what pandas does. And matplotlib allows us to create graphs, which we are going to do a lot in this tutorial. Not in this tutorial, but throughout the journey. Just one second. Okay. All right. So as PD means the same, we are using that library as PD, as PLT, right? That's all. And then what do? We just shift enter, same as Jupyter Notebook. Everything as same as Jupyter Notebook, we'll just write shift and enter number here. So for me, it's 2 because I executed it twice, but for you, it'll be 1. All right, now that is done. So to just, you know, make sure that it's, all right, let me do one thing. Let me just write it here. So we'll be writing what we are doing. So we understand that what is happening. So what we have done right now is we have imported library. Okay. And a comment in Python is written through hashtag. Okay. So we have imported a library. Now we'll come to the next cell. All right. So what's the next thing that we need to do? We need to import the data set. And because it's like this, we'll just write it as a comment. Okay, import the data set. Now we're going to import the data set. So here comes the part where what we imported is what we're going to use. So I'm using a variable called data set. You can use anything, but if you use data set, it'll be easier for you to follow along. So it's a variable. We understood the part where what is a variable, what is that in our first lesson. So we are going to proceed now. So what we are going to do is we are going to read what we just had had here. So if you haven't uploaded it, you will get an error. So what we are going to do is PD. Now what is PD? Pandas. Okay. So PD read CSV. Now why read CSV? Because it's a CSV file. So I'm going to write the code first and then I'm going to explain. All right. So here what did we do? We created a dataset variable. We used our pandas library from which we needed an object called read.csv, which is a function or a method you can say. We needed a method called read CSV, and which is the CSV that we need, data.csv. Here we are not implying the, for example, if it was in sample data, you would have to give the whole path of the sample data, then it would have given you. But here, because we have uploaded it here, it's fine. All right. Okay. Now we're going to create a variable called x. All right, x, and this is pretty important. So I want you to follow along. Okay. So now we have used the data set and imported it. We have read it. Okay. Now what we need to do? Let's just you can, yeah, you can use that, or you can use Google Colab. Because yeah, because firstly, if you're using it on Jupyter Notebook, it is going. You need to install these libraries first. For example, if you want to use or import these, you'll have to install all of this. Like Harshit said, pip install NumPy. You need to install NumPy, Pandas, and Matplotlib for that. So that is why, for the sake of simplicity, I'm using Google Colab, right? Okay. So x equal to data set. That's what we did. Now, what's the next thing that we'll do? Now we read from the data set and we'll use ILOC. The first thing you've heard of it, I know, but okay, bear with me, I'll tell you. But first of all, let us see what the data actually was. So we understand the data first. Okay, let us see. All right. So this was the data. Okay, let us understand the data first. So it has a, I did not want to open this. Okay, so this was the data. We had a country column. So we have a few countries. This is all. This is a very small data set. We had a country column. We had an age column. We had a salary column, and we had a purchased column. Now, from what we understood a few minutes before, we want to predict something, and I want you all to answer according to what we studied before. What can be the thing which we need the model to predict? Any answers? Anything you might feel that okay, this is what we might predict? We talked about this. We did not talk about the exact data, but we talked about this. Anything in from this data? We have four columns: country, age, salary, and purchased. There is one thing that we need the model to predict. What is that? I'll give you a hint: independent variable and dependent variable. So one of it is independent variable, and one of it is an dependent variable, and some of it is independent variable. So now you might get an answer. So one of it is dependent variable, and three of it are independent variable. So okay, no answers, no issues. I'll tell you about it. Okay. So the thing is, what we discussed a few minutes before, we discussed that there are two types of, in any data, there are two types of variable: independent variable and dependent variable. Dependent variable is what we are going to predict, and independent variable is what we use to predict. Okay. So to understand that, in any data set, in most of the data sets, the last column is always the dependent variable. It's always the data that we want the model to predict. So in this case, it must be purchase, right? We want them to purchase. We want the model to predict that if the country is this, if the age is this, if the salary is this, have they purchased it? So if we give it a test data now, will they purchase it? Right? This is what we want the model to predict. So three of this means country, age, and salary. These three are features. Using this, we'll be able to predict purchase. Okay. And purchase is the dependent variable which we are going to predict. So you might be saying, you might be having an question that, okay, purchase is already here. What we are going to predict, right? Now, if we are using a test data set, so from this is the whole 100% data set. From this, we'll be using 80% and keeping it aside. 20% will be using for the test data set. So the test data set that we are using, it will have a purchase column of its own. But what if we introduce some new data, right? We can do that. What if we introduce some new data to it? We give it a country as Germany. If we give a different age, we give a different salary. What if we do that? Then what will the user purchase it or not purchase it? That's what this data is all about. And that's what machine learning is all about. Okay, so let's do that now. Age and salary independent. Yeah, you're right. And country would also be independent. All right. So now we did this. Now let us understand this line of code. Let me write another line of code so you understand it better. All right. So now that we have understand that from this data set, we only need we need to divide the data set into two parts. One part, not the test and training. That is another thing that we'll do. But now we need to divide it in the part of dependent and independent. One part will be where which will be used to predict, and one part which will be the features which we are going to use to predict, and one part will be which is going to be predicted. So this is going to be predicted, and this is going to be, you know, used to predict the data. All right. So here, country, age, and salary is what we need as feature, and purchase is what we need as the dependent variable. Right. So how do we do that? We need the first three columns, and we need this as a separate column. So that's why we created X and Y. So in X, what we are doing is we are using a method called iLoc, which means locate index, right? Locate index. And what is the index? Index means this one, okay? This one. This is the um, index of the data. And this is what we use from NumPy, because we have imported NumPy. This is a method that we can use. Okay. Now we had used list, if you remember, right? List may what we used to do is that if we had to, for example, access the last most element, we used to do that through -1, right? For example, if I create is equals to 1, 2, 3, 4, 5. Okay. And let me first run this. And then if I need to access the last most element, remember there was a way where we could 0, 1, 2, 3, or we could just write -1. So this would give me the fifth part. But what if I write -1? Now what does this mean? So a colon or a colon, if we put a colon there, it means I want to include everything from the start. Just exclude the last one. So this one and this one is a bit different. If we include a colon and then write any number, for example, if we write -2 here, what does it mean? We are excluding the last element and the second last element, and then we want everything from the start. Sounds fair? Okay. And if we write -2 here, obviously it'll give me the second last element, that is 4. So now using this logic, come back here. Dataset.ilocate, and now we are using firstly this. Now what does this mean? This means a colon means everything. Okay, we want everything. So first we write the rows, that means rows, and then we write the columns. So rows and columns. So in the rows, we want everything. We want, like, if the data starts from here, we want to come to here. All right. So we want everything from the rows. And we write, we only want the, like, see, the last row or the last column is what we need, because that's only the dependent variable. And this is a like a small data set, so we know, okay, the last two, oh, 1, 2, 3, and fourth one is here. We know it. But what if it is a very large data set, right? There are like millions of features, and then there's this last column which has what we want to predict. How do we do that? This is how we do it. We want everything, like we want every like we want everything from the like the vertically we want everything, and horizontally we only want till here, and just exclude the last one because that is what we are going to use as a dependent variable. So this is what we are doing. We used a colon to exclude everything, then we used a comma. And okay, rows is done. And now let's just jump to columns and the same logic. Okay, we want everything, just exclude the last thing. So here we are excluding the purchased column. Sounds good? Sounds fair. Now dot values is we want the values as well, right? We want the values. So values is in the France 44, 72,000, another rows. Okay. So if we just like if we did not write the values, dot values, it would have just given us the cells, which is wrong. We want here, and you might incur some errors as well. And now that is done. In X, we have stored country, age, and salary. Now we want a variable we have to where we have to store the purchase data, which is the dependent variable. Now how do we do it? Come back to list. If we want the last one, the last column, like or the last value, the last index, how do we do it? We write -1. It gives us the last column, right? So this is the same thing, but we are just excluding the colon here. Why do we do it? Because now we want the last one and we don't want anything from the start. So here a colon means we want everything like from top to bottom, and a -1 means we just want the last column. Okay, so this is what it means here. And dot values again, the 1 second. All right, where did this go? So sorry. I I lost the notebook. Okay, 1 second. It might be here. Okay. All right. So now we have X and we have Y. I hope you have understood what does this mean, but I'm only also going to write it. So we have country, age, and salary, and here we have a person score. All right, sounds good. Okay, now let's execute it. If this gives you an error, you might have written something wrong. You might have missed a colon or a comma. This should not give you an error. Or if it gives you an error, you might not have imported this correct. Or if you have written data, the D would not have been capital. So just make sure everything is pitch perfect. If you're getting an error, just make sure you write it in the chat box. I'll help you out with it. Or our participants are kind enough to help you out. All right, okay. Now this is done. Now let's see what X is. So print X. Now if we print X, we are getting France, this and this. We're getting the countries. Now why we are not getting country, age, salary, and purchased? Because we do not want this. We only want the values, right? That is why we use dot values here. And I know for a fact that France is a country. This is the age. This is the salary, right? We do not want the headers. This is what data cleaning is. When you get a lot of data, you do not want the headers. Headers just confuse the data set. So we do not want that. Now if we print Y, what are we getting? No, yes, no, no, yes. Sounds good. Okay, so this is a matrix if you look at it, and this is also a matrix. Okay, all right. So now before this, I want to talk about feature scaling. So what is feature scaling? Now we have got this data, okay, but if you look at it, we have some not a numbers. N means not a numbers. So like if you look at it, here are some missing values, right? How do we ensure that the missing values are not there? We'll do this, but we'll do this in the practical class where we meet each other, because this is something that I really want us to understand face to face. But before like we jump to that part, I want you to save this with all your heart, because here is where we'll continue. But we'll come back to this once again to review. But now let's understand about feature scaling. Feature scaling is a very important theory part to understand. I did not want to waste time uh, teaching you feature scaling in class because there we have like strict 1 hour. We cannot go further than that, right? So let's understand feature scaling here. It's not a theory part. It's just something. It's a practical, and you love doing it. So I want you all to be interactive here, and let's just do it. Okay. So give me 1 second. All right. So now anything written here should make sense to you. Everything that is written here, dependent variable, independent variable, this all should make sense to you. If it does not make sense, the recording would be uploaded. I want you to go ahead, review Python, and then review all of this, and then come back. This would all make sense to you. And for example, if any line of code, and if any line of code does not make sense to you, ask me. I'll be sure to repeat it again to you. All right. So okay, let's come back to feature scaling. Now, okay. First of all, feature scaling, before understanding feature scaling, we need to understand one thing, that feature scaling is applied on columns. Now, what does that mean? I'll tell you. Okay. So feature scaling is applied on columns, which means here. So if I want to apply this feature scaling, I'll be doing it on one single column and not across columns, which means I cannot do it here. I cannot do it here. This is a wrong approach. So this is how feature scaling is applied. Now, there are many types and many techniques of feature scaling, but there are two types of mainly teachers feature scaling. Okay, normalization and standardization. If you have done DBMS as a course um, in our college, then you might have an understanding of what normalization means, right? So we're not going into DBMS now. Let's just understand simply word to word. So, for example, we had a data there, right? Now we want to compare. We want the model to compare that, okay, if this is A and this is B, no, let's just take the example that I've used there. So you'll get it really understand easily. So now we have a salary and age. This is the salary and this is the age of a person. And be vigilant because we are going to use this. So I want answers from you as well. Be very good to know. Now we have a person A, we have a person B, we have a person C. Person A has a salary of 70,000, age of 45 years. B has this, C has this. Now, in a normal machine learning model, we want to understand that B is closer to this or this. Now you need to take this into account as well. B is closer to this or B is closer to this. Now, is B closer to A or C? How would you do it? How would you do that? Because see, you do not have a particular way to compare, right? Now, this is a salary and this is a salary and this is a age. You cannot compare salary and age because they are two different variables. We want to normalize it or we want to standardize it in a way that we have a way to compare them. Like for now, if we want to compare it, the difference is 10,000 here. The difference is 8,000 here. But here the difference is only 1 and here the difference is 4, right? Now, if I ask you, B is closer to A or C, what would be your answer? Anyone? A random guess. If we do not have any technique to do it, what would be your answer? 1 second. All right. A as per the difference in age. Okay. A as per the difference in age. So Now you look at it, you're using age as a comparison factor. But also, Archit, you can just save it as a link. So this link that you're using is saved. So if you just click share, you can send it to anyone. So this is how you save the part. So you're saying A as per the age difference. So you are saying that okay, this is a bigger number and this is a smaller number, or this is a lower number. So this might be the reason why. Okay, I'm not sharing my screen. So sorry. Okay. So you're saying that A is closer. So for your understanding, you might be saying that okay, this is 10,000 and this is one. This might be closer, but salary and age cannot be compared. So the answer is quite different from what you think. So to make sure that this is in a comparable format, so that we can compare all of this, we use normalization or standardization. We're going to do standardization in a practical format, but normalization is what we are doing right now. And how we are doing it? Let's do it. So here's a simple formula, a mathematical formula. I hate maths, but yes, sometimes maths does not leave our way. So okay, let's see. So this formula, what it does is it gives our value in 0 or 1. So anything that we compute from here, our values would be in 0 or 1. So it makes things easy for us to compare. So this is this x value would be computed through this. Now let's understand what this means. And this is the last thing that we'll do. And after this, you can leave. Okay. Okay. So let us do for A and B and C and both. So here we are using salary and here we are using age. Okay, A, B, and C. All right. So this would be transformed into a number of 0 and 1. Let's see how. So we have X. So if we are doing it for A, the X value would be the original value that we want to compare. So it'll be 70,000. Okay. Let's come to X minimum. So in this column, remember, feature scaling is done through columns. All right, not across columns, through vertically. It's done vertically. All right, so here what's the minimum value? Okay, the minimum value is 52,000 divided by x max. What's the maximum value here? 70,000 is maximum, and minus x minimum. What's the minimum value? 52,000. All right, anyone kind enough to do this calculation for us? Anyone? You can first let us write the values and then we can do the calculation. Okay, now let's come to B. The same thing that we are going to use, x minus x min. So here x would be 60,000. Why? Because we are using x to compare. X, we need to transform x, 60,000, minus what's the minimum? Minimum in this column is 52,000 divided by maximum minus minimum, x max minus x min. So maximum here again is 70,000 and it will be 52,000. The only value here is changing is, like for example, A is changing, B is changing, and here C will also change. Whole thing will remain same because in this whole column, minimum and maximum are the same. So here 52,000 minus 52,000 divided by 70,000 minus 52,000. All right, we'll do the calculation in a bit. Okay, now age. Let's do the same with age. We're using 45, so let's just use 45 minus what's the minimum age? Minimum age here is 40 divided by what's the maximum age? Maximum here is 45, and what's the minimum? 40, right? X minus X min, X max minus X min. Okay, now we're using 44. This is what we're using now. 44 minus 40. 40 is what? 40 is the minimum value according to the formula x minus x min by x max minus x min. And then what's the maximum value? Maximum is 45. Here, what's the maximum age? 45 is the maximum age minus 40, which is the minimum age. All the values will be the same because minimum, maximum, and maximum is the same for all the for this column. All the values are same. Just Here, this will change. C will change. C here is 40. So this is 40 minus 40 again, because the minimum is 40 and then maximum is 40 minus 40. Now, to save time, I know you guys must have calculated it for us, but I won't be opening the chat because again, it'll take some time. So I'll calculate it for us. Okay. 70,000 minus 52,000 divided by 18,000. Okay, so 18,000 is 1. So it's 1 here. 60 minus 52 is 8,000 and 70 minus 8,000 divided by 18,000 is 0.44. And then 52,000. One second. All right, so this was 0.44. This was B. And this was 1. And C will be 52 minus 0. 0 by anything is 0. Okay. For each 5 by 5 is going to be 1. 4 divided by 5 is going to be 0.8. And 0 by is 0. Now let's see. Now our A, B, and C, salary and age would be the same. Now A, B, and C, we have 1 here, we have 0.44 here, we have 0 here, according to these values that we calculated just now. And this is the formula that we used. Now this would be 1, 0.8, and 0. Now, if I ask you the same question, that B is closer to A or C, what would you say? Now, if you look at it, B is closer to, so we want to see if it's closer to A or C. This is closer to 0 and this is also closer to 0. So just round it off. This is closer to 0, right? And this is closer to 1. So, but because 0 is what is closer to us, here we'll use 0 and here also we'll use 0. So it is closer to 0. So this is what feature scaling is. This is how we compare if the value is closer or not, right? Now once we have the values in, for example, ones and zeros, it is easier for us to compare even the largest data set. If we take an average in both columns and B is closer to it, you can take an average definitely, and that is what is used in standardization. So standardization and normalization are the two methods that we use in feature scaling. So you can take the average, but average has a different formula. For example, if I just mirror my screen again, in standardization, we have the value as x. We know what the x is, x minus average by standard deviation. So this is how it is calculated, right? So I hope you understand what this part is, okay? And this is what feature scaling basically in theory is. But when we uh, like compute this practically, this will be a lot more intuitive for you. You will be seeing this happening in real life, which will make it even more interesting for you. So at the moment, what we have done right now is we have done simple data pre-processing, but we haven't got into the main parts like treating the missing values. And we'll do that as well. Do not worry, but we'll do that when we need. Okay. So anything and everything that you have learned from this session would be the basic, pillars for you to proceed ahead. And once you understand what is happening, you will be able to understand what is happening in the next sessions as well. So now we have put down the foundation for the machine learning parts that we are doing, and we are going to do this even further, like treating the missing values and everything. So we'll be doing this, but we'll be doing this in the next session. So thank you guys for joining us on a Sunday and joining us this late. And it was really a pleasure for me to interact with you guys. The recording would be available on our YouTube channel. You can definitely refer to it. And thank you, everyone. I hope you found this session informative. And if you did, I would just appreciate a thumbs up from you guys. So I understand that, okay, my efforts were like, it went on really well. So thank you. Yeah, Chirag, go ahead. Okay, you raised a hand like that. Okay. Thank you guys. Thank you so much. That really means a lot to me. So a feedback form will be shared in a while so that I can really understand how can I improve in the future sessions. But if you have any um, suggestions for me at the moment, you can stay in the meeting. I would be I'd really happy to listen to it. If not, thank you for joining. And let's, okay, didn't understand how 0.8 is closer to 0 instead of 1. So, okay, see, let me just share my screen again. So in a normal real life scenario, if we round it off, obviously 0.8 is closer to 1, right? But the reason why 0.8 is closer to 0 is because we are using this as we are doing feature scaling in this column. Okay. Now, here in this column, it was closer to 0 because now we round it off, it will be closer to 0. But in this column, 0.8 is closer to 0. We are not rounding it off. We are using a data. So if the data is, for example, say like very long, you would be going to the like preceding value to you. So if we precede 0.8, where we'll be going to 0. So whenever we are comparing anything in feature scaling, in normalization, we normalize it in a way that it always uses the preceding value. So because the highest it can go is 0 and 1. This is the highest you can go in normalization. In standardization, the value can range from -3 to +3. But here it is we go to the preceding value. I hope you understand that. So because the highest is 1, so this is the reason. And I hope you understand this. But if we are going to do this practically, like if we have, yes, we can definitely use the previous one to go, like the previous value to go. For example, 0.8 is closer to the preceding value, which is 0. So yes, we can do that. So the floor value, exactly. We use the floor value. So once we do the standardization as well, we use floor there. So it'll be very understandable to you. So in theory, it seems a bit clumsy, but it'll be better understood. So yeah. So I hope this is informative. So if there's anything else that I can help you with, I'll be very happy to do it. Okay. So if this is all, then thank you guys. Thank you for joining us. And I'll be sharing a feedback form on the group, and I'll be really hoping you guys fill it up with total honesty. And it'll be anonymous, so I don't know who is filling what. So yes, that's all. Thank you guys. Thank you for joining today. So I should just end the recording first.